So thank you, everybody. Thanks for joining us for this November session of the PANAP webinars. So as you, I guess, all know, today we are looking at a recent study with which is exploring how trade policy can support low carbon development in developing countries with a look on Kenya. So we have three panelists that we already thanks for their presence and their availability to present the work. The first presentation will be from Andrea Meligi. So he will present somehow a way to look at greenhouse gas emission data for Kenya. So Andrea is a colleague at the Joint Research Center. Well, I didn't present myself. I also Emanuele Ferrari from the JRC Seville. With Andrea is a PhD in economics and management, and is specialized in national account and social metrics and input-output, and is part of the PANAP, let's say, with his work on data. Then the second presentation will be how this data, looking at how this data on greenhouse gas emission can be included and how can be used then in modeling, and in particular in the single country general equilibrium model that is developed within PANAP. From this, we have Amarendra Sao. He's also a former colleague at JRC and is now with the Tilburg University in the Netherlands, and has extensive experience in economy-wide modeling, input-output and policy analysis, in particular on looking at macro development, agriculture, food security, poverty, environmental, and trade. While he has been working with a lot of institutions before JRC and the European Commission, particularly IFAD and the PEP network, and is also has been a longer and part of PANAP. And finally, we will look at the case study, so where all these data and modeling have been applied for a concrete policy analysis. And this will be presented by Shadrach Mwatu, who is a senior policy analysis with the Kenya Institute for Public Policy Research and Analysis, also known as KIPRA, which is a government research and policy analysis think tank under the Ministry of National Treasury and Economic Planning in Kenya. So Shadrach has been utilizing CG models since he joined the PANAP network. He also presented this work at the last GTAP conference within the Young African Research Session. He has a PhD in economics. He is a PhD economics student and also master degrees in economics and a bachelor degree in economics and statistics. So we will try to have the first presentation around 10 minutes each. Perhaps if there are any questions after the first presentation, we can start taking them, or the panelists can also, if you use the Q&A or the chat to send questions, they can also answer in writing. And then there will be a bit longer presentation for the case study by Shadrach, around 30 minutes. And then we'll dedicate the remaining time to answer, getting additional question and answer through a Q&A. We can also raise your hands, and we can hear the voice of the participants in case you want to raise the question directly to the panelists. Okay, so unless there is anything else to add, I think I will leave the floor to the first panelist. So Andrea, perhaps I will let you know in 10 minutes or more or less, if I see you're not close to the end, I will let you know that your time is about to expire. We see your presentation, but not in presentation mode.
No?
Nope.
Okay, very good. Let me try again.
Maybe slideshow?
Yeah.
So let me try again from... What about now?
No, same as before.
And we also tested.
Yeah, very good.
Okay, try again. Let's try this way. Could you see it now?
Not, yeah, okay, go ahead. If you can
Okay.
remove just there is a small, okay, go ahead.
There's the banner.
Yeah, go ahead.
Okay, so thank you, everybody. I'm just going to present, let's say, the multiplier approach. So every time we have an export demand shock, what would be the effect on the emission? And then we will also see together an indicator and a tool we prepared. So why this effort? Because basically we can address this emission impact also from a multiplier perspective, which is basically coming from our starting framework, which is the social accounting matrix. And from that framework, which is very useful for running the CG model, but we can already have a preliminary analysis of which are the main driver of economic variable, macroeconomic variables, and in this case is going to be about emission multiplier. So the main database we use for addressing the emission coefficient is the GTAP database 11, with the emission updated to 2017. So this set of emission coefficients are the one taken into account in our framework and are treated for as a satellite accounts for the modeling framework we are going to use. I'm going to go quite quickly on the methodology, as I don't want to stress too much on that side, but then I will give you all the references in case you want to read more about how we dealt with all the components of the sum, and also on how we dealt with the rationale behind the tool we are developing. So in this list you're seeing right now, you have different types of emission, are mainly input and output based emission. Most of them are by activities. Some of them are by households, and we have also endowment-based emission coefficients. So the first thing was in this effort was to distinguish where and when emission are generated, if they are input or output based, and which part of the multiplier matrix we have to activate in order to assess this impact from a commodity shock into our economic system, and then for addressing then the emission multiplier impact. So this is the methodology we used. So it is based on the social accounting matrix. The endogenous part of the social accounting matrix is what we are considering in our multiplier analysis. We are considering exogenous the investment, government, and the exports. Okay, so in these two equations, you could see how we address emission by activity and how we are addressing emission multiplier by household. Okay, so in the case of the emission multiplier by activity, we basically have summed up all the emission coefficients and also first sum up and then also consider separately, and then multiply this for the output multiplier part of this inverse matrix. So once we compute the multipliers through the inverting the endogenous part of the social accounting matrix, then we obtain a multiplier framework, and part of that multiplier framework is then computed to obtain then this emission multipliers. Okay, so and this is the part related to the multiplier which are related to activities, so input or output based. And then we have a part related to the emission multiplier by household, which is calculated based on the income multiplier, which is another part of the inverse matrix we are considering, the exogenous shock, which is in this case is the unitary shock, and the propensity of consumption, so that we use to address how a shock, how the effect of the income then would increase also the propensity of consumption of household, and then would generate even more emission. And so we are considering also this loop effect. I'm going directly to the first results. Okay, so this is the emission impact due to the commodity demand unitary shock, both in intermediate and in output production. And in the yellow part, you will see the share of the endowment, which is activated by the emission multiplier. So we calculated two different types of emission in this case: the emission related to the intermediate and output, and the part related to the endowment. So the part related to the endowment is basically what is coming from the factors of production. So in this case, you could see that the yellow bar, the yellow part of the bar, which is mainly related to agricultural sectors. This is because the emission there are concentrated mainly in the factor livestock and in the non-irrigated land. Okay, so let's go a bit farther. The emission here are expressed in a kiloton of CO2. Okay. Then we have, as I mentioned, this induced effect, which is generated from the demand shock also on the income, and then with an increase in income also would increase the propensity of consumption for the household, and then it would generate this sort of emission impacts, which are divided by household. So you could see different types of household. In this case, we have quintiles for the Nairobi and Mombasa. And then we have rural and urban disaggregation for the other provinces of Kenya. In this case, we are talking about agroecological zone, okay, just to make this differentiation. So the green part, the green bars are related to the increase in consumption of wood, so emission related to the increasing consumption of wood. And the orange part is related to the one related to the petroleum, so oil refined, so fuel basically. And the dark green, which you could barely see, is the one related to the chemicals. Okay, so particles, mainly particles. Okay, so this is the perspective of the multipliers tool we were able to create. Of course, we can have much more granularity considering all these coefficient types. But in this case, as we have only 10 minutes, so I've preferred to skip that part. But we can even go into more details. Then I would like to briefly introduce a combination of two multipliers. This is an exercise we've run already with an article we published, and then I'll share also the references. So we created a complex indicator. It's a multidimensional indicator, which is called employment intensity of carbon, which is combining two types of multiplier, the employment multiplier and the emission multiplier. So basically, this employment, we call it employment intensity of carbon, which examines how the goal of job creation resulting from demand-side policies can be translated into emission, basically. And this is expressed in terms of CO2 equivalent emitted, okay? So in this chart, for example, we can see that the highest employment intensity of carbon are observed mainly in the crop and in the food processing activities, especially those related to other manufacture of food, which is the highest bar, and which create around 4 jobs per ton of CO2 equivalent. So every time we have an exogenous shock of the demand in that sector, then we would have 4 jobs per ton of CO2 created. And then we have tobacco, for example, and which is about 3.5 jobs per ton created. And then cotton and fibers and the sugar cane, both above 2 jobs per ton. But we can also go more in detail if you're willing to understand also at which in which region, in which agroecological region this is taking place. So, for example, we can clearly see that most of this impact are created in the high rainfall zone. So if we decide to go more into the detail and so also examine not only by region, but also getting into more granularity and exploit all the part of the sum we have disaggregated. In this case, we have not only labor factor by region, but also by skill. We are able also to get into the detail of the high rainfall region. So, and we are able also to identify if these jobs are created more in the semi-skilled or in unskilled jobs. So, for example, in tobacco sector, a unit increase in emission of 1 ton of CO2 equivalent in the high rainfall region is associated with around 2.5 additional unskilled jobs, compared with about 1 semi-skilled job and almost 0 skilled jobs. So this is just to illustrate how this indicator is largely driven by unskilled and unskilled employment in this region. Just to conclude, I'll try also to promote a bit a new tool we have just developed in-house. I would like to thank also our data scientist Javier Castro, which helped provide in creating the tool online, which you can access from this link, or you can scan the QR code. And this tool is basically replicating what was my example related to the input and intermediate, so input and output based emission and endowment by activity. So you're able to calculate by a unitary shock in percentage or absolute value, which would be the impact of that sector across the economy by emission expressed in kilotons CO2 equivalent. Perhaps I have still a few minutes for showing the tool. I don't know, Emanuele, please.
No, you don't,
advise.
but please go. Please go ahead. Go ahead.
Okay, so in case you also want to have more granularity and also more, you want to read a bit more about this composite indicator and also how we previously deal with the emission calculation and also this employment intensity of carbon. This is our publication, which you can find to this link. And I think
if you want to take 1 minute to share
okay.
the calculator, go ahead, but really 1 minute, please.
Yeah, okay, I'll share the screen. Okay.
Yes.
Give me 1 second. I have to move from the other. Perhaps I should do like this. Could you see it?
Yes, yes.
Great. So this is for those that are familiar with the jobs calculator, is working exactly in the same way. So we can create a shock, which, for example, in this case, could be related to the tea commodity, an increase of the tea commodity export, and we can create also decide to go for an increase of the demand. And for example, then we know that an increase of in the export of 100 million Kenyan shilling then will result in 7 kilotons of CO2 equivalent generated by that sector. And here you have also the more granularity in case you want to dig a bit into which are the gas types involved. In this case, you can see it's CO2 emission, and then you have SO2 and CH4. So you can dig a bit more, and also exploiting the bar chart could be also give you more drill down options. So in this case, you will have a first drill down option, which is by activity. So in which activities this emission are created. So it's mainly transport. We can dig then to see which are the emission which are the gas type which is the more pollutant, and we have CO2, CH4, so and so on and so forth. So I think we can share this in the chat.
I already put it in the chat, Andrea. Thank you.
Okay, so I think
both. Yeah.
I think for my side it's good. Thank you.
Thank you very much, Andrea. So yeah, both the GHG calculator and the jobs calculator and the chat. You'll see at the moment the GHG is only for Kenya, but the idea is to expand it to other countries too, while the jobs calculator is already covering a wider range of countries in Africa and also EU countries based on EU social accounting metrics that the JSC is developing, and Andrea in particular. Thank you very much. So as said, if there are any questions, please put in the Q&A or directly in the chat. I don't see any at the moment. In the meanwhile, I pass the word to our Amar, your friends, that will do the link between the data and the modeling before entering then in the case study. Right.
Thank you for inviting me. So good to see you all again. Let me share my. Okay, to see. Let me see if it is coming to as a slide. So no. Okay, now it's okay, no? Good to go.
Yes, now it's okay. Please go ahead.
Okay, great. So, good afternoon, everyone. And this is just a quick, I'll just quickly go through the how we have incorporated this emission into the Demetra CG model. It's very simple way. So it will take just short, it's a lot shorter than 10 minutes probably, hopefully. So the first thing is that Demetra's how its module works. Like we have a greenhouse gas emissions, which are taken care of in the module itself. We have a module inside the main model. So, and we have two types of emissions, as already Andrea has already explained a little bit that side as well. So we have CO2, which is combustion, and non-combustion emissions, which is non-CO2 and also some carbon oxide as well. So there are 38 types of categories of non-combustion emissions. And how you calibrate? So the source of calibration is based on the GTAP data set. So mainly GTAP dataset. Let me quickly say something about it, because why we use this GTAP dataset? Okay, it's availability. Second is that it has also included a lot of, like for the CO2 emissions, is taken care of, like International Energy Association, energy agencies, for example, what you call World Energy Balance for the from this kind of sources, and also for non-CO2, they have taken like from Edgar, and that is our European Commission's Edgar, and also FAO, and similarly also there is a U.S. Environmental Protection Agency. So based on everything, so it is more reliable. So let me go to the tracking. How you track this emissions, combustion emission in our model? How you have taken care of it? So basically, we linked the fuels. So we have fuels like how the fossil fuels, we have for like coal, oil, natural gases, gas, and petrochemicals, that is oil-based product, and other gas in the sense gas like manufactured gas as well as distribution gas. These are the fuel types of fuels. And this, how is it coming from? CO2 comes from like CO2 from the activities and households. GTAP gives from the domestic production as well as from the import on the activity side. So we have combined it as activities, production as activities. And there are use of energy from the household side as well. So coefficient, we use the coefficients, and we provide the coefficient to the researchers of the different country, I mean our partners and researchers, and we compute these coefficients based on the database data set from data. Why I'm just, it's not looking at this one. Okay, so we did the aggregations, like it could be aggregated on the active by activities, it could be total plus activities and households and the total overall economy. So we get many types of can be done as we wish. So then we have how the model logic works, like activities, emissions. We have like calculated as emissions coefficients. We have coefficients. I will come back to that later. We have coefficients that we have computed from based on the GTAP data. Then use the coefficient times multiplied by the amount of specific activity, specific fuel used by activities. So basically that is for the activity emissions for CO2. And for the household emission from the CO2 for CO2, we have similar thing, emission coefficients in multiply by, and we multiply it with the total household use particular fuel. So then we aggregate the way we want, and we have the total emission for the overall economy. And this is creating issues with me. Okay, then come now on the non-combustion emissions. We have 38 types of emissions, and then Andrea has already taken care of many things as mentioned about it. So that is based on the non-combustion. So it could be output-based emissions, use of output, and also intermediate input, which is process-based. There's 5 drivers, actually emission drivers, and it could be from the fossil fuel related, like non-combustion as well, non-combustion fossil fuel related emissions, and emission from endowment, like land and capital, and then the household-based emission, that use of household use, from the household use, the emissions coming from the use of households from there. So we have non-combustion. Then how it is in the used in the model, like we have output linked, as I said, the 5 drivers, it's the solar taken care of it. Okay, sorry. Okay, so in the model, we use that output linked. Similarly, like we have emission coefficients. For the output-based driver, we use the coefficients, emission coefficient multiplied with the total output of an activity. For example, rice activities, it produces methane. So this is for the methane coefficient from the rice activities. That is for the output-based. And process-based, for example, like CO2 emission coming from the chemical process. So this is a process link. So this is the coefficients we use, like intermediate use input of that CO2 use. That's the process based. Then fuel related, that is non-fossil and non-combustion fuel based is like burning of certain things, raw materials. So that is there are different types of emissions coming from there, like NS3 or something else. So it is taken care of by them. Then we have endowment waste, which is for example, N2O from the fertilizer land or use of fertilizer land. Basically, I mean, it has capital and I mean, mostly it's a land waste actually, mostly land waste emissions. Then household consumption, emission coefficient we have, multiply the household consumption of a particular commodity that emits, that creates pollution or the emissions that is taken care of. This is a way we have incorporated into the model. So I'll quickly go through the data calibrations. As I said before, that GTAP is our base data set, and we use it for our baseline. So emission coefficients are prepared. JSC is responsible for this. JSC researchers and modelers are responsible for these coefficients. That's prepared by the JRC modelers. Okay, main challenges are how to map it because this is the main part, and because of the and we have the different inconsistency between the inconsistency between sorry, inconsistency between GTAP data, GTAP classification, and the MECRA classifications, because there are different classifications, differences are there. So what we have to do is that we have to match somehow the data. But the goal is that we keep the CO2 and non-CO2 emission and the aggregated emissions, greenhouse gas emission for a country given. Like this has to be calibrated because that's given by GTAP. Whatever GTAP has the CO2, aggregated CO2 and aggregated non-CO2 emission and total emissions, that should be given. We have to calibrate it to that one. So focus on the activities, like for example, CO2, now mapping the CO2, we have subgroups. So we have created subgroups because detailed activities cannot be mapped because GTAP has different types of activities and also each country has different socioeconomic metrics and activities. So what we did is the subgroups, we created subgroups like agriculture, livestock. Agriculture could include forestry and fisheries and livestock, then energy activities like crude oil, and it depends. Like suppose in energy we have mining, which doesn't have crude oil as such, but if mining is producing crude oil, so we assume that mining is there. So we under the energy we put the mining, right? So crude oil, coal, natural gas, petrochemicals, and also the gases from the distribution or other types of gas, like other types means gas, but through the manufactured process is created. So CO2, this gas based. So this is the energy. We subgroups, we created activities as subgroups. Then manufactured food, manufactured food, then other manufacturing and electricity and services. These are subgroups. Then we map it to the GTAP. So then the non-CO, similarly for the non-CO2, non-combustion emissions, we have, like as I said, it is like 5 drivers, but besides the output waste, like activities, we have also other drivers, like as I discussed before, like process-based and intermediate input process-based and also non-combustion-based households. So we also need commodity map as well. Besides activity mapping, we need commodities. So activities mappings are same as like CO2. Then for the commodity mappings, we have, for example, 5 type of like matches like forestry, wood, lumber, energy commodities. Not all the commodities should be matched. These are the commodity matched, which is responsible for the emissions. For example, forestry, wood and lumber, and energy commodities, non-metals, chemicals, and fertilizers, gas manufacture, and distributions. We should keep in mind in the Mitra modelers, when we do it in GRC, for each country, we have to do different types of little bit of adjustment for our mapping, so that which could be very close to the what we get it like. And at the end, the calibration should really match to the GTAP's the total emission of a country, the total greenhouse gas emission or CO2 and non-CO2 emissions of the country. So we have equations, as I said, that is a model
Amar,
GMS.
sorry, can you try to go to the end of the, sorry about that. Sorry to interrupt. Please go ahead.
Sorry, what did you say? Go to the
End of the presentation. If
yeah. So basically, then we have a these are already taken. We have a GTX file. We give it to the for the calibration purpose, and we use it for the calibration. And I said that total GHG emissions will have like we have CO2 and non-CO2 total. We give this in, and for the policy simulation, as Sadrak will present now, and also our friend has already presented on this input output like multiplier analysis. We can do many of this impact analysis, and with some modification of the model, original module, we can do many of this. For example, pricing, carbon pricing, and etc. So as we say that we have CO2, these are repetition of the things. I don't have to say this thing again. And it's a robust analysis because we have to really don't go for any um, detailed mapping classification, but still it's useful for the researchers. So that's all, and they are the bit of references. And thanks a lot.
sorry, Amar, I had to
No,
interrupt
it's
you.
okay.
All right, thank you very much.
Let me speak.
So before we switch to the next, in the meanwhile, if Shadrach wants to upload the presentation, just a quick remark. So as I said before, if you have any question, please feel free to add at the moment in the Q&A. Thank you very much for the presentation. Just a quick remark on my side. So if you are using, or if you have been using the Metra model so far, you have realized that you won't have the possibility to use this extension that has been just presented. So we are working on, let's say, finalize and make it consistent with the rest of the model, and perhaps also add more countries and release it to the public as soon as we can. So we're working in PANAP to do this as soon as possible. But if there is a concrete interest to use the greenhouse gas emission in your day-to-day policy analysis, if you're already using the model and there is also an interest in using that, please just let us know, and we'll try to implement or share with you the data also for the country you might be interested in, or the Kenyan one, which are already being shared with some of the other stakeholders in Kenya. On top of what Tamaris said, we are also working on a modeling extension. This is not yet available. It's something we are still working on, which is introducing and implementing carbon pricing in the model, so that you will be able in the future also to run analysis on around simulation and the possibility to see the impacts of on emission, but on the whole economy of how the introduction of carbon price in selected countries would impact, as I said, emission and the rest of the economy. So this is also an opportunity in case there is an interest on this that we are all happy to share with whoever might have an interest on doing this type of analysis. This said, I'll leave the floor to Shadrach Moatu, is presenting the first policy case studies that is looking using the work on an emission that has been presented so far. So he will present some of the policy action for low carbon development in Africa with a specific focus on Kenya. Shadrach, the floor is yours. If you can, stay in half an hour, perhaps a few minutes more, no worries. And then I repeat for the last time, if for any question, you can use the chat Q&A or raise your hands at the end of Shadrach's presentation. Please, Shadrach, floor is yours. Go ahead.
Thank you so much, Emmanuel. I'll take you through this presentation, building on what Andrea and Amar have presented to highlight possible policy options for transitioning African countries as developing countries towards low carbon development, but drawing specific insights from Kenya. Getting to the presentation, we noticed that Kenya is among the second largest emitters of greenhouse gases within the African continent, at par with countries like Ethiopia, Sudan, Morocco, and behind countries like South Africa, Algeria, Nigeria, and DRC. And what we are noticing is that greenhouse gas emissions for these countries are expected to continue rising as these economies expand and continue industrializing. We notice that Kenya's greenhouse gas emissions are rising as population is rising and as the economies are expanding. As population grows, demand for meeting needs of the population, needs like transportation needs like heating and lighting needs within places of living residences, needs for more goods and services within these economies will likely put pressure on the economies to produce more, and the economies produce more, we shall also experience a rise in greenhouse gas emissions. Therefore, with this scenario in mind, the question will be, how can we be able to meet the needs of the growing population? How can the economies expand and industrialize in an environment where greenhouse gas emissions is reduced to lowest possible? So we notice something else is that the country's greenhouse emissions from land use change have been declining over time. But interestingly, emissions from use of fossil fuels and the industry within the country rising, as you can see in this chart. And it is actually projected that by the year, sorry. Okay.
No, nothing. Go ahead, please. No.
Yes. I'm trying to see my slide. Okay. And it is projected that by the year 2030 in Kenya, use of fossil fuels and the industry will be the leading contributors to greenhouse gas emissions. We also noticed that the increased consumption of fossil fuels in generating electricity within the country, in meeting transportation, meeting domestic and commercial and industrial needs, will also be key contributors to the greenhouse gas emissions in the country. And this is also this case is also replicated for other African countries which face similar conditions like Kenya. We look at this against the country's green transition plan. We see that within the second nationally determined contribution, what we call NDC, the country plans to reduce greenhouse gas emissions by 35% relative to the business as usual scenario of 215 metric tons of CO2 equivalents by the year 2035. And to achieve this, the country commits to transition away from use of fossil fuels towards use of green energy, and in the process be able to reduce emissions. And to be able to achieve this, there have been questions about what will be possible ways of ensuring that we can be able to transition the economy away from use of fossil fuels towards cleaner, green, more efficient energies. And with that, we are seeing that low carbon technologies, which are energy efficient, could actually support this transition by supporting reduction of energy consumption, reducing greenhouse gas emissions, and ultimately being able to reduce or to support our development that is low carbon, which is key. Looking at how to be able to achieve that low carbon transition, we see that these developing countries within Africa and within Kenya for that matter face domestic capacity constraints, which make them unable to domestically produce the low carbon technologies, which we are saying are energy efficient and could therefore support energy efficiency, reduce energy consumption, and therefore be able to reduce greenhouse gas emissions and support a low carbon development. So if these developing countries in Africa and from the prism of Kenya have these capacity constraints, then how can we be able to achieve to gain access to the low carbon technologies? And we are seeing that there is an option, and therefore now trend comes in where we are saying that developing countries like Kenya could be able, in the short term, in the medium term, could be able to access the low carbon technologies from developed countries through trade, which is key. And looking at currently, we notice that these developing countries in Africa and for Kenya specifically, we see that they are actually highly dependent in terms of importing the machinery and equipment which embeds the low carbon technology, and also in terms of importing petroleum products which have been serving as energy sources. For machinery and equipment which embeds the low carbon technologies, we see China is currently a larger supplier of the low carbon machinery and equipment, supplying 50% of the what Kenya uses. Behind that, we have the European Union playing a significant role there at 17%, UK, US, India, and the rest of the world. But in terms of access to petroleum products, we see much of the petroleum products then are coming from the rest of the world, with India, China supplying a marginal amount of water the countries is using. In terms of dependency, we see that for Kenya, in terms of machinery and equipment, which embeds the low carbon technologies, we see importing dependency for machinery and equipment is 69%. Import share in total imports is about 16%, and effective tariff is 8.3%. And with this 8.3% of an effective tariff, which is applied at the customs when these low carbon machinery and equipment are entering Kenya, if it is reduced, then we could enhance and support access to the low carbon technologies. In terms of petroleum products, you can see we have a 75% import independency and 26% share in total imports, and an effective tariff of about 2.6%. So you can see the effective tariff currently on petroleum products is lower than the effective tariff on machinery and equipment, yet petroleum products have more adverse effect on the environment in terms of greenhouse gas emissions compared to the machinery and equipment, which embody the low carbon technology. And if we could have reverse in terms of the policy priorities, such that we reduce the effective tariffs on the imports of the low carbon technology, machinery and equipment, then we could support these economies drastically transition away from using fossil fuels, which are emitting greenhouse gases, towards low carbon technologies, which are energy efficient and could therefore support the transition towards a low carbon development. Something else we look at in terms of the policy options, we look at two financing options to access these low carbon technologies, which are embedded in machinery and equipment. The two options are one, domestic resource mobilizations, and then the second one is financing through support by the international community. You will realize that within the NDC, the National Indeterminate Contribution, Kenya has committed to raise about 13% of the resources needed to support mitigation measures domestically. So these resources have to be raised by the Kenyan government, and the larger chunk of the resources needed to support the mitigation measures have to come from support by the international community, especially within Article 9 of the Paris Agreement, where developed countries supporting developing countries to transition towards the net zero. And within this arrangement, we see that the option for domestic resource mobilization, we look at a scenario where we completely remove the tariff, the custom duty that is applied on these low carbon technology, machinery and equipment when they are coming into the country. And by doing that, by eliminating the custom tariffs on the imports of low carbon technology, machinery and equipment, what we are doing is that the government is foregoing the revenue, the tariff, the customs revenue that it would have earned. And by that, the direct fiscal cost is borne by the Kenyan government. We do it such that the 100% elimination of custom tariffs on imports of the machinery and equipment, which embeds the low carbon technology, leads to a 32.57% increment in supply of the machinery and equipment, which embeds the low carbon technologies for use as intermediate inputs within the industrial sectors in the country. That is for the domestic resource mobilization. But for the international support by the international community, we look at a scenario where the international community supplies the energy efficiency improving machinery and equipment through lower market prices, through lower world market prices. And the scenario we do is such that the two scenarios, the scenario for domestic resource mobilization and the scenario for international support by international community, both of them eventually increase supply of machinery and equipment as intermediate inputs by that 2.57%. But in doing that, we notice that world market prices for the low carbon technology machinery equipment declined by about 7.74%. And this again would encourage access to the low carbon technologies embedded in machinery equipment for use as intermediate inputs by developing countries in Africa. We also noticed that within the international community, within the Paris Agreement, the international community commits to supporting developing countries' transition. The next step, we look at the production nesting, because in the previous slide we have argued that we have fossil fuels which are used as intermediate inputs in the production process by the industrial sectors. But we are saying that because the fossil fuels are emitting more greenhouse gases, there can be a substitution away from use of fossil fuels towards use of the low carbon technology, machinery and equipment as an intermediate input in the production process. Therefore, what you see here is that there is going to be a substitution away from use of fossil fuels as intermediate inputs in the production process towards use of machinery and equipment, which embeds the low carbon technologies. The low carbon technologies, we are saying that they are energy efficient, and having them would support energy efficiency, reduce over-reliance on fossil fuels, reduce greenhouse gas emissions, and eventually transition the economies towards a low carbon development pathway. So it is expected that the ultimate outcome will be a reduction in use on demand for fossil fuels and a rise or increment in demand for the low carbon technologies. And the eventual effect is a reduction in greenhouse gases. We go directly to the results. Looking at the macroeconomic results, we see that the two policy options: one, domestic resource mobilization, where the fiscal burden is borne by the government of Kenya by foregoing the tariff revenue, which could have been earned from the tariff applied on the imports of machinery and equipment, which embed low carbon technologies, and supported by international community. We see that these two financing options, as two policy options, have positive effects on macroeconomic variables. So you see what is happening at GDP. GDP rises, increases. You see what is happening to exports overall. Exports increase, imports increase, and the imports are increasing partly because we are also encouraging access of the low carbon technology, machinery and equipment as intermediate inputs in the production process. But within the NDC, the nationally determined contribution target for Kenya, Kenya plans to be a hub for green energy transition within Africa. And a striking result we see here is that these two policy options will support achievement of that, because we are seeing that exports of the machinery and equipment which embody the low carbon technologies will grow significantly, which is important. Overall, we also notice that greenhouse gas emissions overall decline with about 4.26% for this scenario for domestic resource mobilization, and 3.99% for the scenario considering support by the international community. A striking insight you also see is that the supply or the demand for machinery and equipment, which embodies the low carbon technologies, increases, but in demand for petroleum products, which is a fossil fuel, decreases. So there is a shift or a substitution away from use of fossil fuels in the production process towards use of energy efficient low carbon technologies in the production process. So this substitution will not be perfect substitution. It will be imperfect substitution in the sense that you won't fully replace use of petroleum, but you'll be able to drastically and over time reduce its use in the production process. So we see that, and the decline in use of fossil fuels would be good for African countries which are developing and which are also heavily reliant on imports of energy, especially petroleum products, because that would also reduce their import bill for fossil fuels, and this would also have a positive effect on their current accounts, would have a positive effect in terms of cushioning the countries against price volatility, which has been associated with energy products, especially petroleum products across the world, as we have noticed over time. Something else striking that we also notice is that the effects of financing through support by the international community seem more pronounced than those for domestic resource mobilization. This maybe reinforces the strategy, Kenya's strategy, to have the largest chunk of the financing coming from support by the international community. Not to say that the country should not commit to raising resources domestically to support mitigation measures. Next, we see that greenhouse gas emissions from combustion of petroleum products decline by about 0.72 million metric tons of CO2 equivalents, which is about 4% of the total greenhouse gases, which will be reduced. So we notice that much of the reductions in greenhouse gas emissions would occur in the industrial sector, about 0.37 million metric tons of CO2 equivalents, and also followed by services sectors, about 0.33 million metric tons of CO2 equivalents. So this will be important. And you see one characteristic of these African economies which are developing. The economies are largely service oriented, and as they industrialize, then this will be important for them to ensure that they're industrializing in a low carbon environment. For the sectors that we examined within this piece of policy work, we noticed that much of the greenhouse gas emissions reductions would occur in the construction sector, about 0.17 million metric tons of CO2 equivalents. And again, for Kenya, under the current administration, the construction sector is a focus sector in what we are calling within the affordable housing program, whereby the government has focused on making the country a construction site, and therefore embracing these technologies which are embedded in the machinery and equipments would ensure that the construction sector also transitions towards a low carbon, it becomes more green. So we see that reducing greenhouse gas emissions by the 4%, which is about 0.72 million metric tons of CO2 equivalents, would cost about 52 million US dollars in foregone tariff revenue by the government. Remember, we had said that the government was tapping into the revenue from the tariffs applied on these low carbon technology machineries when coming in, but it has to forego that revenue to now ensure these low carbon technologies are accessible to the country. And this would happen in a scenario where reducing a ton of greenhouse gases would be costing about 73 US dollars. But the issue, in as much as the government has to forgo the 52.75 million US dollars in revenue, we see that this cost seems to be recoverable, is recovered through improved GDP, leading to higher direct and output tax revenues of about 50.26 million US dollars. So the loss domestically, the fiscal implication domestically is not so severe, and therefore developing countries like Kenya within the African context should not fear embracing this policy option, because we see the additional revenue recoverable through growing GDP, higher direct taxes and output taxes is also high. We look at the effects of these two policy options at a sector level. And again, for the first scenario of domestic resource mobilization, which reduces custom tariffs on imports of machinery and equipment which embody low carbon technologies, we see that much of the reduction in greenhouse gases is observed within the petroleum, construction, chemicals, and mining sectors. These are essentially some of the dirtiest, quote unquote, dirtiest sectors in the sense of emitting greenhouse gases in the production process. Petroleum demand decreases in all sectors, as you can see. Here, it decreases in all sectors, but demand for machinery and equipment, which embodies the low carbon technology, here, as you can see here, increases in all sectors. This is key in the sense that it supports the transition or the shift away from using fossil fuels in the production process towards using low carbon technologies, which we said are energy efficient and could reduce energy consumption, and in the process reduce emission of greenhouse gases in the production process. For the second scenario, the sectoral effects under the second financing option, where we consider support by the international community, we notice that value added increases in all sectors. As you can see here, it increases in all sectors. Demand for petroleum products, fossil fuels, again, as you can see here, again, it decreases in all sectors. And overall, we see that demand for low carbon technology, machinery and equipment, this one increases. So again, we see the transport, the energy, construction, chemicals, mining and metallic minerals, petroleum, and the other manufacturing sectors, which constitute the industry, would become more green in the sense that overall greenhouse gases by sector decrease, as you can see here. Greenhouse gases decrease, and use of low carbon technologies increase, and demand for petroleum goes down, showing the substitution away from use of fossil fuels and transitioning the economies towards a low carbon development. So overall, we notice that there is a transition away from fossil fuels, sources of energy, towards energy efficient, low carbon technology, machinery and equipment, which are very key. And again, we are having this discussion at a time when the world is pay attention to COP 30, where issues of mitigation, green transition are a priority. In conclusion, we look at the insights that we've seen from this work. We examined policy options for lowering costs of accessing energy efficiency, improving machinery and equipment that imperfectly substitutes fossil fuels in the industrial sectors. And we notice that developing countries in Africa, and from the prism of Kenya for that matter, could consider trend-related policies to facilitate access to low carbon technologies to support their mitigation actions within their nationally determined contributions commitments. So liberalizing or removing tariffs completely on these commodities will support that transition. It's one of the policy options. We also notice that developing countries will be able to reduce sales taxes as another option, in addition to eliminating tariffs, custom tariffs on these commodities. They could also reduce sales taxes now domestically after these low carbon technology machineries have landed into their territories. They could also ensure that sales taxes is also reduced to further encourage retailing and uptake of the low carbon technology machinery and equipment within these economies. We also see that developed countries would fulfill their commitments within the Paris Agreement to finance and transfer low carbon technologies to developing countries through lower prices to support developing countries in Africa be able to now transition towards a low carbon development. We also notice that developing countries like Kenya and others within the African continent could incentivize development of skills and knowledge that is needed to produce the low carbon technologies locally. So, but this could be more of a long-term measure. For the short term, the priority should be opening up, liberalizing, removing the tariffs, the international communities supporting the developing countries to ensure that developing countries have access to these low carbon technologies embedded in the machinery and equipment to build the domestic capacity. And in the long term, remember the scenario we saw about what is happening to exports. In the long term, as the developing countries build their capacities, then they can start incentivizing their workforces to have the requisite skills and knowledge to build domestic capacities. So something else we see in terms of extending the work that we did, we could have inclusions to more precisely include clean technology within the data set, which could support the policy work and reduce what we saw as the amount of forgone custom revenue that the government would forgo. If that was to be done better, also the amount of custom tariff revenue the government forgoes could also go down. And lastly, we are proposing for more research specific to low-income countries and different economic, trade, and emission structures to ensure that developing countries within Africa are able to customize policy options, trade-related policy options to their scenarios, to their contexts, to ensure that they gain this low-carbon development pathway for the betterment of a more greener globe. Thank you. That's it for me. Back to you, Chair.
Thank you very much, Shadrach. Thank you very much to all the three presenters. I think it was a very, very nice and enlightening presentation that showed not only the possibility of the model within increased, let's say, enriched by the greenhouse gas emission, but also overall how the model can be somehow very provide a very policy relevant answer to specific question. And I think it was very well presented by all the presenters, by Shadrach in particular, or the case study. I would be definitely happy to get any question from the public, from the people that are attending the seminar. So as I said, please feel free at this point either to write in the chat or to raise your hand, and I'm happy to give you the words and open up the mic and ask a question. Right. In the meanwhile, perhaps I can start. Quick question. So, Shadrach, if I can start from you, if I just raise a quick question. So you mentioned some of the future research. Also based on what I mentioned before your presentation, if you know, which I will be eager to understand which are the plans, you know, in terms of climate policy from the Kenya government side. Whether you expect, for example, that carbon prices will be one of these policies, and how do you think, you know, then if there will be opportunity to further use this modeling framework that has been developed to support your government in any request that can soon come in terms of additional policy, climate policies, also in view of what of the discussion that is taking place in Belém these days. Shadrach.
Thank you. Thank you so much, Emmanuel, for that good question. Yes, in line with the work we've done and what the government of Kenya has committed to do within the second NDC, where the country is committing to reduce greenhouse gas emissions by 35% by the year 2035. We are planning to ensure that there are clear policy priorities targeting the green transition, because one of the gaps we noticed was that in as much as the government has made the commitment to transition the economy towards the low carbon development pathway, some of the policy options, for example, by how much, if we were to reduce tariffs on imports of low carbon technology and machineries, how much should we reduce by, and what other policy options should be considered? Those are some of the areas where we see an opportunity to support the government, have sessions with the government to iron up, saying these could be potential policy option which can support this objective, this target within the NDC, and ensuring that there is a follow-up, even in the coming up with the finance hacks, to ensure that subsequently and gradually all the low carbon technology commodities coming to Kenya have been mapped out and they have been prioritized in ensuring that they do not attract any custom tariff by when they are coming into the country. So we want to ensure that we work closely with our Kenya Revenue Authority and also with the Ministry for Environment and Forestry, and also our parent ministry, to ensure that this is prioritized and given a concrete priority in subsequent planning sessions in the budget and also in the finance acts that will be forthcoming. And also even being able to tell the government, this is the list of commodities which could support the economy transition towards the low carbon development. Be able to tell them specifically, this is the list of the low carbon commodities which we should prioritize. So that is an area where we see an opportunity and a gap to support the government. Yes.
Thank you very much. Like in the meanwhile, so I see Andrea added the reference to the paper, including the indicators on jobs and environment and greenhouse gas emission that he presented as the first panelist. And I also included the link to the GTAP paper that is somehow the reference now for this last presentation, where you can find the paper and the presentation that Shadrach delivered at the latest GTAP conference. I think the paper will be also public soon, no? If I'm not mistaken, it will be available from journal soon. Andrea, Ahmad, is there anything you want to add? Also on the in view of what Shadrach has presented, also in terms of future research and how this work can future support the work in the countries. Omar, I see you switched on
Yeah,
your
but
camera.
no, I don't have much to think. I think you have already discussed with him before, so it's okay. I mean, we have. I think it's a good work. I mean, probably as you mentioned before, like we can start. He has already proposed something like that, or maybe you can have carbon pricing later if it's like other countries are doing it. Now it has become really popular in some of these countries, not yet, but still they're picking up. In Western Africa, also carbon pricing, so one can try for that one. So
Yeah.
for East African countries as well.
Yeah,
Andrea?
perhaps just we could brainstorm maybe with Shadrach also about the new tool we are developing. Being on Kenya, it could be valuable also to have the insight of Shadrach to see if we can improve the tool. And very soon, so far we have only results by activity, but we will also add the part in the tool which I presented on the household. So we will have also that effect which is capture once the income receive a boost, and so new consumption are gonna be created. Yeah, so definitely we can explore a bit more together also that the tool.
Yep. Thank you. Another aspect that probably has not been mentioned, but where there are also additional work with colleagues in Kenya is related to the land and the land use change. So it's a thing that at the moment has not been mentioned, but where there are ongoing work on see how we can quantify also impacts on environment that comes from that side too. So it's probably if I would have to add also one of additional point of future research, where as I said there is already ongoing work, so perhaps we will be also able within PANAP to present additional tools to evaluate also that that part of the economy. All right. Okay. I mean, I don't want to keep people busy. I'm sorry that there are no additional questions. I hope this is because your presentation was extremely clear. But yeah, we shared in the Okay, sorry, I was reading the chat. I share in the chat the materials where the presentation where somehow reference to the paper. We can also share the presentation if you are interested in the next days. Just for me to close, unless there is anybody else also on Kwaku and Farah side to add anything. We will try to have the last webinar of the year at the beginning of December before the Christmas break, and then start in 2026 with a new wave of webinars. As usual, I will encourage you to follow us in our LinkedIn Stepfos site. Perhaps, I don't know if Daniel is there, if you can add the link, or through the PANAP newsletter, so you will be timely informed about the activity of the PANAP the PANAP's network. I put the link to the newsletter in case you haven't subscribed yet and you want to be subscribed. And this said, I think I will again thanks the three panelists, Andrea, Marendra, and Shadrach, for the very nice and very interesting presentation. And thanks all my colleagues that support this PANAP work based in FARA. And thanks all the attendees that have followed the seminar. So thank you very much for your time, and I hope to see you soon in the next week, and then in the new year for the other webinars that we will present to you. Thank you very much again. Thank you.
Thank you.
And see you soon. Cheers.
Thank you.